So let's take a look at the native solutions provided by these firewall vendors, and then we'll talk about what Aviatrix is solving or doing in this space to solve those challenges. So let's take a look at Azure. So if you look at Azure, Azure have a native firewall, right? So in the diagram, you see this is your Azure firewall, right? So it's natively available by Azure, and you can deploy it in active-active fashion. But the problem is that when you want to send this traffic from, let's say, this spoke VNet to spoke VNet number 2, you need to make sure that you have all the UDR done properly. You point it to the VIP of the load balancer, and then it goes to the firewall, and then to the destination. But if you're running it in active-active mode, then you have to deploy the SNAT or configure SNAT so that the return traffic should go here, right? And it's not hitting this firewall, for example. Otherwise, it will break the traffic. So these are the problems we see. But the good thing about at least this Azure firewall is that it can give you the SNAT automatically, so you don't have to configure it. But on the other side, if you look at the third-party solutions, for example, if it is a Palo Alto VM or any third-party VM, and if you want to deploy it in active-active fashion, basically the challenges are same, right? You have the long and inconsistent failover in HA. You are configuring or deploying some script to make sure your HA is working properly. When it comes to managing it, again, it's a pain to program all these routes, the UDRs into the system, right? So it's a very high complexity, high management that you need to do for the Azure. And SNAT is not done automatically. So you have to configure SNAT if you want to deploy these firewalls in active-active fashion. Okay, so that was Azure. Let's talk about AWS, what native solutions they have. So in case of Azure, they don't have their layer 7 firewall. So they are heavily dependent on the third-party vendors, for example, Palo Alto, Checkpoint, or Fortinet. So again, when you are about to deploy this firewall in AWS, okay, so you want to deploy it in active standby fashion, but the problem is that this can only be deployed in one AZ, one availability zone. So that's one limitation. So you are paying for both firewalls, you're paying for the licensing for the both, and also the instance cost, but you are getting on the performance only from the one firewall, which is active at a time, right? Again, the configuration is also manual, right? But the good thing is that since they have this concept of TGW, you can attach this VPC, right? Yeah, this VPC here with this AWS TGW, and you get about 50 gig of throughput. That's what they claim. But again, you have to manually configure the route in the VPC table so that you can send the traffic towards this firewall, and then this firewall will send traffic back to VPC number 2, and then the return traffic should go through this firewall, which is in active standby case. Yeah, it's obvious only one is active, so you don't have to do any SNAT or anything. But again, it's a complex process you have. Okay. Now I'm trying to find my pointer here, mouse pointer. Where did it go? Okay. I lost my. Okay, got it. I think it happens when I try to annotate. Okay. So yeah, so that's one option. Okay, what about the second option? The second option is called the IPsec VPN model. So in this model, what happens that you see this TGW in the middle, right? Now you're not attaching this TGW with this VPC. You are building an IPsec tunnel towards this firewall. And why? Because now you want to run these firewalls in active-active mode. Okay, so if you want to run it in active-active mode, that means you want to use ECMP, equal cost multipath. That means you need to enable BGP, but since these guys are not directly connected, you have to build the IPsec to do all this, right? And even when you build the IPsec, the problem is that this IPsec is only going to give you 1.25 GB of throughput. right? This is what we also learned in the previous section. So effectively, what happens that you only get about 500 Mbps because the traffic will go to this firewall and come back in. So yeah, so even if you have purchased, let's say 6 GB license from Palo Alto, you're gonna get about 500 to 600 Mbps throughput. And this is what I'm talking about when you are deploying firewall in just the basic plain mode. If you enable any advanced feature on this firewall, the throughput will even reduce further, okay? So that's the thing. And then SourceNet, that's another big challenge. Why? Because since these guys are running in ECMP mode, and you want to make sure the traffic that hits the firewall is the firewall that is receiving the return traffic as well. So yeah, so a lot of challenges there.